Alright, so Suki here is training for this 100-meter race. Her initial starting speed here is 2.7 meters per second. Her max average speed is 6.6 meters per second. Her practice run is 18.1 seconds, and it's a 100-meter race. And what we are trying to find here for number 28 is how many meters long is her initial acceleration phase. So one way we might do this is go 2.7 meters per second times, let's say initial is x and max average is y. So if I have 27 meters per second for the initial phase, this is the amount of the number of seconds she is in this phase. And then plus 6.6 meters per however many seconds she's in this average speed of her max time here. That is going to get us this many meters for this many seconds plus this many meters for this many seconds at these speeds. That's going to get us to 100 meters. Now the seconds, I can just say x plus y, total number of seconds for the initial part, total number of seconds for the max average part. That is going to be 18.1 seconds. Now, I'm really just concerned with this initial phase here. So what I'm going to do is I'm going to solve for y and plug my initial stuff in for y so I can find the value for x, because I really just want to find what x is for this question that I'm being asked. So I'm going to subtract x from both sides, and I've got negative x plus 18.1. That's my y value, and I'm going to plug that into this first equation that I created. So now I've got 2.7x plus 6.6 times negative x plus 18.1 equals 100 meters. Distribute this 6.6, that gives me 2.7x minus 6.6x plus 6.6 times 18.1, 6.6 times 18.1, which gives me 119.46 equals 100. Now I'm going to combine my like terms. 2.7 minus 6.6, that gives me negative 3.9, and I'm going to subtract 119.46 from both sides, 119.46. So that gives me negative 3.9x equals negative 19.46. Divide both sides by negative 3.9. So I've got 19.46 divided by 3.9. And that gives me x equals, it says round to the nearest tenth of a meter, but that gives me, so I've got 4.987 seconds. So now I just plug this into, I multiply my number of seconds with the meters per second, and that should give me the answer that I'm looking for. So I go 2.7 times this. That'll give me the initial phase, because this is how many seconds she's in that initial phase. So I go 4.9897 times 2.7, oops. And that gives me about 13.5 meters. There we go.